Guys, for all the solutions of this book, visit forthesakeofeducation.com. I've been working hard of putting all the problems into one convenient place for you to be able to do your homework easily. So pay us a visit.
Alright guys, this is this problem that says determine the tension of the cable and the horizontal and vertical components of reaction at pin A. The pulley at D is frictionless and the cylinder weighs 80 pounds. So this is 80 pounds. So we have this tension at B, and that is the same tension at this point right here. At A we have a vertical reaction, let's call it F of AY, and a horizontal reaction, let's call it F of AX. And then we have F of C, which is equal to 80 pounds. And let me take it out of down there to avoid confusion. Oops. Sorry guys. Now, we have these variables. Let's just write the variables that we need right here, which is F of AX, F of AY, and T for tension. So we have three variables. Now we have this nice little triangle right here. And I'm just gonna make this clear right now. This is 2, this is 1. If this is 2, this is 1, Pythagorean theorem, which is a squared plus b squared equals c squared, then you can calculate c to be square root of 5. Let's just do that. A squared plus b squared is equal to c squared. So 1 squares 1 plus 2 squares 4 is equal to c squared. That's square root of 5 is equal to c. And you'll see why we need that in a little bit, but usually I like to get all my triangles and angles that I know I'm going to use straight up from the beginning. Okay, so in the x, let's assume this is the x and this is the y direction. So f of a in the x is going to the right, so it's positive, minus t, the tension, this tension right here, because this tension is going straight up. It has no x component. And this tension, as we can see from this triangle, the x component of this tension can be calculated by multiplying by 1 and divided by the hypotenuse. And I don't know if you heard that, but that was my cat running in the background. Sorry about that. And that is equal to 0. So we have our first equation. We need three equations because we got three variables. In the y, we got one tension going up, which is this tension right here, plus another tension going up, but this tension has a y component. This is the y component of this tension. This is the x component of this tension that we calculated before. This y component is equal to t times, according to the triangle that we just drew, is 2 over square root over 5. And that gives us the y component of the second tension, minus the weight, which is 80 pounds, plus f of a in the y, almost forgot, is equal to 0. So let me rewrite it. F of a in the y plus 1.894t by adding the two t's together, minus 80 pounds is equal to 0. And that is equation 2. All we need is one more equation, and we're going to do sum of the moments at A. And I'm going to assume that counterclockwise is positive, and that is equal to 0. So where's A? A is right here. Why did I pick A? Because we have f of A of x and f of A of y, which means we have two variables that we can knock out if we do the moments about A. So moments about A is equal to the moment created by the first t, which is t times the distance from A to B, which is 5, and it's positive because it's going counterclockwise. The second one is the y component of the second t, because the x component is creating no moment, but the y component is. And that is equal to t times 2 over square root of 5. That's the y component of that tension, times the distance from A to the point where that tension is being applied, which is 5 plus 5, which is equal to 10. And it's also positive because it's trying to turn counterclockwise. And the last but not least is the 80-pound force, which is negative because it's trying to turn it clockwise, times the 80 pounds. And the 80 pounds you have to multiply by the distance from A to C, which is equal to 13. And this is equal to 0. And we only have one variable in this equation, so this problem is turning out to be pretty easy. So we have 5t plus 8.944t by multiplying this fraction by 10, minus 80 times 13, which should be 1040, which is equal to 0. So 13.944t is equal to 1040. T is equal to 74.584 pounds. We got T. Now we can plug this into equation 1 and we can solve for f of a of x. And we're gonna get that f of a of x is equal to t times 1 over square root of 5. F of a of x is equal to 33.355 pounds. And then we can plug this into equation 2, and we can actually not this one. Sorry, we can plug this into equation 2 right here. Sorry about that, guys. Right here, and solve for this one. And we will get that f of a of y is equal to 80 pounds minus 1.894t, and we plug in t, and we get that f of a of y is equal to minus 61.26 pounds, which means that the reaction at f of a is going in the opposite direction that we assumed. We assumed it was going up, so in reality it's going down. So let me write down the final answer right here. The f of a reactions in Cartesian form is equal to 33.355 in the I minus 61.26 in the J. And this is in pounds. And the tension is equal to 33.355 pounds. Final answer for this problem.